And the greatest common factor is, what is the greatest common factor? Let's take a look. The greatest common factor of two or more integers of which at least one is not 0 is the largest positive integer that divides the numbers without a remainder. Let's take a look at an example. It's easier to see. The greatest common factor, also abbreviated GCF, of 24 and 16 is 8. This is because 24 is divisible by 8 and 16 is divisible by 8. What other numbers are factors of 24 and 16 but aren't the greatest common factor? 2 and 4 are factors of 24 and 16, but 8 is larger, and we're looking for the greatest common factor. How can you find the greatest common factor? Find the factors of each number and look for overlapping factors. For example, 24 equals 2 times 2 times 2 times 3. 16 equals 2 times 2 times 2 times 2. The overlapping factors are the 3 2's. So 2 times 2 times 2, which equals 8. And that's where we got 8 as our greatest common factor. What is the least common multiple? And what is the difference between the least common multiple and the greatest common factor? Let's take a look. The least common multiple, abbreviated LCM, of two integers a and b is the smallest positive integer that is divisible by both a and b. If either a or b is 0, the least common multiple is defined as 0. Let's take a look at an example. It's much easier to see. So what is the least common multiple of 4 and 6? So find the multiples of each number and compare the results. We don't have to find all the multiples, just keep going until you get some overlap. You can see that you have a common number in each. So multiples of 4 are 4, 8, 12, 16, 20, 24. And multiples of 6 are 6, 12, 18, and 24. Multiples on both lists are 12 and 24. Since 12 is the lower number, it is the least common multiple of 4 and 6. So what is the difference between the greatest common factor and the least common multiple? The greatest common factor is a number that divides into the two whole numbers, as 8 was the GCF for 16 and 24. The least common multiple is a number that the two whole numbers divide into, as 12 was for 4 and 6. The rational number system is often shown on a number line. There are many ways to represent a number line, and we're going to take a look at a few. Rational numbers can be positive or negative. We deal with positive numbers every day: time, weight, and height, for example. Some of the numbers we live with can be positive or negative, such as temperature. Take a look at a thermometer. It has positive degrees, 0 degrees, and negative degrees. 0 acts as a center point, having a 0 value. You can think of 0 as nothing or empty. 0 is considered to be an even number. It's the smallest non-negative integer. It is a whole number and therefore a rational number. There isn't universal agreement on whether or not 0 is a natural number. It is one of the most interesting numbers in mathematics. Can you see that plus 0 degrees and minus 0 degrees are the same distance from 0? What happens if you remove the positive and negative signs? They are the same number, 20. What do you think minus 20 means? Not 20. Two negatives equal a positive, so minus 20 equals 20. Is there a negative 0? 0 is its own negative. The number line can be extended to coordinate axes, also called a Cartesian plane. The rational number line is at the top. Fractions aren't shown there, but they should be included. And we call that the x-axis. Below it, we have the coordinated axes. AXES is the plural of axis. We have the x-axis and the y-axis. We also have several ordered pairs. 2, 3 is in green. That's the ordered pair. 2, 3. 0, 0 is the ordered pair at the intersection between the y-axis and the x-axis. We also have, in the third quadrant, negative 1.5 and negative 2.5. You can have fractions and a rational number coordinated axes. Let's take a closer look at the coordinated axes. Things you should notice: the ordered pair 5, 5 and the other ordered pair negative 5, negative 5 differ in sign only. The second ordered pair numbers are negative. The two ordered pairs are in different quadrants. If you draw a line from the ordered pair with positive numbers to the ordered pair with negative numbers, the line transects or passes through the 0, 0 point. What happens if ordered pairs have mixed signs, such as 5 and negative 5, and 5 and 5? Notice that the line drawn between the points represents distance or length. Here's another example of ordered pairs on the coordinate axes. Things you should notice: the ordered pair 10, 10 and the ordered pair negative 10, 10 have different x-axis values. The two ordered pairs are in different quadrants. If you draw a line between the two ordered pairs, the line transects or passes through the y-axis. Notice that the line drawn between the points represents distance or length. The distance from each point to each axis is the same, y. Finally, let's look at an example of ordered pairs where the points are in the same quadrant. Things to notice: the sign for the x-axis coordinate for each ordered pair is positive. The sign for the y-axis coordinate for each ordered pair is negative. What happens if you connect the 2 points? Does the line transect the x-axis or the y-axis? Y. We've examined points in the rational number line and ordered pairs on coordinate axes. Now let's look at absolute value in the number line. What does the absolute value of a number have to do with its position in the number line? Good question. First of all, let's examine ordering on the number line. Note that going from left to right, the numbers get larger. Negative 1 is bigger than negative 4. Think about it. It's a bit counterintuitive. Any number that is more negative than any other number will always be smaller. Now consider the number line with the blue arrow. Think of it as a thermometer. When it is 10 degrees below 0, it's really cold outside. When it's 40 degrees below 0, it's really, really, really cold outside. Another way to express this is negative 10 is greater than negative 40, or negative 40 is less than negative 10. They are equivalent statements. When the negative sign and the positive sign are used, the expression is called an inequality. Absolute value on the number line is calculated as the distance the point is from 0. For example, the distance from 0 to 4, positive 4, is 4. The distance from negative 4 to 0 is 4. Each is the same distance from 0. Each has an absolute value of 4. Problem 1. Multiply multi-digit decimals using the procedure you learned in this lesson. 72.147 times 457.23 equals what? How many digits to the right of the decimal point will the result of 31.019 times 657.9? For the second part of that question, you can answer it just by looking at it. You can see that 31.019 has 3 digits to the right of the decimal point, and 657.9 has 1, so that you know that there will be 4 digits to the right of the decimal point in the final result. Here are the answers to the questions. You can pull out a piece of paper and do them both and see the results. Problem 2. What is the greatest common factor of 72 and 32? What is the least common multiple of 6 and 9? So let's look at greatest common factor of 72 and 32. We know that 72 is 8 times 9 from your multiplication tables, and you know that 32 is 8 times 4. So if you list out the common factors, you're going to see that 8 is the greatest common factor. The least common multiple of 6 and 9, well, you know that 6 times 3 is 18, and 9 times 2 is 18. So I'm guessing that when you lay out the multiples, you're going to see that 18 is in both lists. The multiples of 6 and the multiples of 9, and that 18 is the least common multiple. And doing the math, the answers are 8 for the greatest common factor and 18 for the least common multiple. Problem 3. The graphic to the right illustrates x is greater than -2 and less than 4. If x must be an integer, what are the values of x? So the pink line with the circles on the end mean that it's an inequality. It means that it's not equal to the circled point, but it includes all the numbers between the circled points. So the integers between, we can see, are -1, 0, 1, 2, and 3. And the answer, -1, 0, 1, 2, and 3. What did you learn? You learned to divide fractions, multiply multi-digit numbers, divided multi-digit numbers, added and subtracted multi-digit numbers. Probably the most interesting things you did today, greatest common factor and least common multiple, they're fun to work with. You took a deeper look at the rational number line, coordinated axes and ordered pairs. And finally, you saw absolute value on the number line and what it means. It's the distance on the number line between 0 and the point.